All right, everyone, we are going to continue with 2.2. We are going to be graphing reciprocals of linear functions. So last unit or last section, we were graphing absolute value of linear functions and quadratic functions. Today, we are only focusing on the reciprocal of the linear functions, so just the linear functions. This is slightly different, okay, than absolute value. However, the very first step would be the same. We actually are going to graph linear functions first, and then from there, we're going to graph the reciprocals. Now, before we do that, I want to look at how the graph or how does the table value show you the pattern, and we're going to use that pattern to graph, as a general rule, to graph the rest of the linear functions and quadratic functions actually, but that's next time. Okay, so first here is the question is asking us to graph y equals to 1 over x. Now, what we're gonna do is we're gonna get the table of values for y equal to x first. Now, y equals to x, that means whatever x is, that's exactly what the y value is. So this is just copy over, right? Okay, no problem. Now, what we are going to do next is then we are going to take these values and then we're going to take the reciprocal of those values. So reciprocal, recall, means 1 divided by whatever number that we had. Okay, so 1 over its original value. So we're going to take 1 divided by -5. This is going to give us negative 0.2. We are going to take 1 divided by -2. That will give us negative 0.5. 1 divided by -1 is -1. 1 divided by -0.5 is -2. 1 divided by -0.1 is -10. Now, here we hit 0. 1 divided by 0 is recalled undefined. Okay, so you can't really divide it by 0. So this is undefined. 1 divided by 0.1 is 10. Divided by 0.5 is 2. That's 1. That's 0.5. And that's 0.2. Okay, so I am going to, oh shoot, I should have used two different colors for the table of values. I am going to, let's see here. Is that halfway? Pretty close. I'm going to use blue for my linear function, okay? So it's going to be 0, 0, 1, 1, -1, -1. We have -5, that's 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, -2, -1. Okay, I'm not gonna draw. Okay, you know what? Oh, sure, somewhere here, right? And then here I'll skip the 0.1, but we'll definitely use the 0.1 and negative 0.1, and we're gonna look at those 2 points later on. 1, 2, 3, 4, 5 here. Okay, so these are the points. We are going to join them together. So this is this graph right here. Okay, so that's the linear function. Okay, now we are going to plot the points for the reciprocal first, and then we're going to look at the pattern, okay? Okay, so when x is -5, the y value is -0.2, so that's somewhere here. When x is -2, this is -0.5, so somewhere here. When x is -1, y value is also negative. So notice how this point remains the same as the blue graph, right? Remains the same. When x is -0.5, this is -2. When x is -0.1, it's -10. I don't think I can actually go down to -10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, somewhere here. Okay. Now okay, we continue at 0, it's undefined, okay? So then that's okay, we'll continue. When x is 0.1, the y value is 10. Do I have 10 here? 1, 2, 3, 4, 5, 6, 7, 8. Okay, somewhere here. When x is 0.5, y value is 2. Sorry, y value is 5. No, okay, when x is 0.5, y value is 2. Okay, so that's somewhere here. When x is 1, the y value is still 1. Okay, so that again is the same point. When x is 2, this becomes 0.5. When x is 5, 1, 2, 3, 4, 5, the y value is 0.2, somewhere there. Okay, so the graph looks something like this if we join the points together. And this goes this. I missed a point. Excuse me, but you see that's the graph. Okay, so let's look at the pattern here. If we go down the list from the blue graph, okay, so if we look at this way and stop right here, for the y values, it goes from -5 to -0.1. So the y values are actually increasing, right? For the blue graph, okay, you know what? I'm going to use the blue pen. So from here to here, the y values are actually increasing. Okay, I don't know if I can. Okay, hold on. Okay, increasing. I'm going to say increase. Now, as we go down the list, for the red part, for the red graph, I guess the reciprocal graph, the graph is actually decreasing, right? You can see the y values are getting smaller and smaller. So this is decreasing. Okay. It gets more and more negative. Okay. So when the y values increases for the blue graph, the y values for the red graph actually decreases. Well, what about from here to, okay, what if we go this way? Okay, so if we look from the bottom and goes up, the y values you can see for the blue graph is actually decreasing here, right? This is decrease. And if you look at the red graph, if we're going up this way, this is actually increasing. Okay, so when the blue graph decreases, the y graph, the red graph increases. When the blue graph increases, the red graph actually decreases. So it's just kind of going the opposite way. Now, here are some key points though. That's this one and this one. And the reason why they are key points is because they don't change. And remember, when they don't change, we have a name for it. They are what we call the invariant points, right? We hopefully still remember this. They are the invariant points because they don't change. Oops. Invariant points. Okay. When x is 0, or when the original the original graph, the blue graph is 0, the reciprocal is undefined. Well, that makes sense because we cannot divide by 0. Okay, so that give us, so this is another important one. This give us the vertical asymptote. Okay, recall vertical asymptote is a vertical line where the graph will never crosses asymptotes. Okay. Okay, so that's basically it. Really, what you need to do when you draw a reciprocal of linear functions, what you need to do is draw the original linear function first, and then from there you can see again. If you look at the graph, if you don't look at table values, let's just look at the graph. Here, what we should do is get these 2 points right away because they are invariant. Okay. Now, if you could start from this invariant point and then goes to the left for the blue graph. If you go to the left for the blue graph, you can see the graph is actually decreasing. And look, what happens with the red graph is that it increases, right? If you look from starting from this -1, this invariant point, and goes to the right, the blue graph is actually increasing. And you can see the red graph is actually decreasing like that. Okay, if we move on to the other side of the reciprocal function, same thing. Starting from this invariant point to the left, the blue graph is decreasing. However, you can see the red graph is actually increasing. And to the right of this invariant point of 1, the blue graph is actually increasing, but you can see the red graph is decreasing. Okay, and we actually have a vertical horizontal asymptote right here as well at 0. Okay. We will talk more about horizontal asymptote in the next unit 3, okay, but that's going to be a horizontal asymptote right there. And vertical asymptote at 0 because that's where the x-intercept was for the blue graph. Okay, so that's basically what it is. And now we just need to look at more examples, I guess. We can read through the definition here. It says the reciprocal of a number x, where x is not 0, is the number 1 over x. Reciprocal function, the reciprocal of a function f of x, and f of x cannot equal to 0 is 1 over f of x, okay? Practice 1 is as determine the equation of the vertical asymptote of the graph of y equals 1 over 4x minus 1. So again, I think we did this earlier in the exponential function unit. Vertical asymptote happens when the denominator, actually no, we didn't talk about this in exponential function. Okay, that's okay. But when to get the vertical asymptote, basically as long as the denominator is 0, that will create the vertical asymptote. And the reason why is because we cannot divide by 0, right? So 4x minus 3, when 4x minus 3 equal to 0, that's when the vertical asymptote occurs. So to find the vertical asymptote VA, all you need to do is solve for this equation. Okay, for x minus 3 equal to 0, because again, once it equals to 0, you have 1 over 0, which is you can't do that. Okay, so now we can solve for x. Bring 3 over to the right, and then divide both sides by 4. You get x equal to 3 over 4, and this is your vertical asymptote. Okay, that's the equation of the vertical asymptote. Okay, so here's the practice question, and I'll do this one with you, and I'll let you do the next one on your own. Okay, so let's see here. Again, the very first step that what we need to do is to draw y equals x minus 3. Okay, so that's what we're gonna do first. So here is my x-axis, and that's just a linear function, so you should be able to draw this quite easily. Okay, the y-intercept is -3. That's 1, 2, 3 right here. The slope of this linear function, remember, is 1, so we go 1 up, 1 right, 1 up, 1 right, 1 up, 1 right. Okay, there we go. That's enough points. Then we are going to join these points together, make it a line. Okay, there you go, something like this. Okay, so that's the first step. The second step is to find your, so to find your, okay, now I'm going to say your find invariant points. And x-intercept of y equals x minus 3. So x-intercept is right here, and remember the x-intercept of the original linear function will actually become the vertical asymptote. So here is my vertical asymptote, because this becomes vertical asymptote, VA. Okay. Invariant points, these would be plus minus 1 for the y value, so that's right here. Okay, because that's the y value of 1, right? That's 1, and that's the y value of 1, and y value of -1, so here is my second invariant point. Okay, so now once we have these three information, that's really all we need to draw the graph of, the reciprocal of x minus 3. So here, again, we just use the pattern. From this invariant point to the left, you can see the red graph, the original x minus 3 graph, is actually decreasing, right? So from here, this is decreasing. And therefore, the reciprocal graph is actually going to increase, okay? It goes the opposite way. It will not touch the x-axis, however, okay? So because we would have the horizontal asymptote right here. To the right, from this invariant point, the red graph is actually increasing, and therefore the reciprocal function, or the reciprocal graph, is going to be decreasing. Okay, so once we are done with the left hand side of the vertical asymptote, we're going to move on to the right hand side. So from this invariant point to the left, you can see the red graph is actually decreasing, and therefore the blue graph is going to increase. It makes sense. Again, I think we talk about this, the graph will go towards the asymptote. To the right, from this invariant point, you can see the red graph is actually increasing, therefore the blue graph is going to decrease, and again, it will not go through the x-axis, because that's our horizontal asymptote. Okay, so if you are okay with this, I guess you can continue and try the next one on your own, see if you can do it, okay? I'll pause, or you should pause and try it. Okay, so I'm assuming you're done, so I will quickly do this. And here's my y-axis, here's my x-axis. First, again, draw y equals negative 2x plus 3. Y-intercept is 3, slope is negative 2, so 2 down, 1 right, 2 down, 1 right. Okay, and we can find the x-intercept quite easily. Okay, we need to have it, right? Because that's important. The x-intercept would be, we just let y equal to 0 and solve for x. Bring 3 over, divide by negative 2. That's 3 over 2, or 1.5. So here. Okay, so there is our y equals negative 2x plus 3. Okay. Second step, again, find our invariant points. Invariant point and x int. Okay, so that's right here. Here, those are invariant points, and our x-intercept actually becomes the vertical asymptote. Okay, this really is the VA, right? Vertical asymptote. Okay, so now again, from this invariant point to the left, you can see the graph. The blue graph is actually increasing, therefore the reciprocal is going to decrease like this, and it will not go through the x-axis. Again, that's our horizontal asymptote. As the graph goes to the right, you can see the blue graph goes down, so it's decreasing, therefore the red graph is going to increase like that. Okay, so that's done for the left hand side of the reciprocal of the vertical asymptote. From this second invariant point to the left, you can see the blue graph is actually increasing, therefore the red graph is going to decrease towards the asymptote. To the right of the invariant point, you can see the blue graph is decreasing, therefore the red graph is going to increase towards the horizontal asymptote right there. And that's it. There is your reciprocal graph of negative 2x plus 3. Oh, I guess we need to state the domain and range. So the domain would be, oh, did I do that for the previous question? I guess I didn't. It would be all real numbers except x cannot equal to 1.5. Okay, I guess I should write the other way around. I don't know if it actually matters, whatever. Usually we write like this, x cannot equal to 1.5, but everything else. The range then would be not equal to 0, right? Because that's our horizontal asymptote, but y could be everything else. Let me go back to the previous question. Does it ask us to write the domain and range? Oh, it does. I forgot to enter it. Okay, domain and range. So the domain here for the reciprocal function is going to be, again, same thing. It cannot equal to 3, right? That's our x-intercept for the x minus 3 graph, but everything else. And for the range, it cannot be 0, but it could be everything else. Okay, y, e, r. Okay, that's ugly not equal sign. There we go, that's better. Okay, you can pause the video and think about it. I need to get a drink of water. I'll come back and I'll show you the last example. All right. Oh, I desperately needed some water, and that felt good. Okay, anyways, let's come back to the last example here. It says use the graph of y equals 1 over f of x to graph the linear function y equals f of x. So we're going backwards. Okay, so here this is given us as the reciprocal graph already. Okay, now we're gonna graph the original graph, so we're going backwards. Okay, so just think about what we did. Okay, remember what we did was we drew the original linear function first. Well, we can't do that right now. And then, well, but basically what we're doing, like I said, we're doing backwards. So it was first draw linear function, right? This was the first step, which we can do right now. I mean, that's what we're trying to do. But what we did was from there, we find the invariant points, right? Invariant points and the x-intercept, because those points will help us to draw the reciprocal function. So we're just going backwards. So instead of going 1, 2, we're going 2, 1, right? So invariant points are positive 1 and negative 1. So it looks like here and looks like here. Okay, that's negative 1. Okay, that's positive 1. That's negative 1. So these are our invariant points. The x-intercept, now remember, x-intercept became the vertical asymptote, and you can see from this graph the vertical asymptote happens at 1. Okay, so there's our 3 points. Perfect, that's all we need, right? There is our linear function. and well, I guess you only asked us to draw the linear function. We could actually figure out the equation of this linear function. You know what, let's do it. So in this case, f of x would be, now the y-intercept, you can see it's -1, so remember this is mx plus b. Now we already know y-intercept is -1, so -1. M is the slope, so if you just look at these 3 points, you can see we're going up by 1, and 1 to the right, 1 up, 1 right, therefore the slope is 1, 1x minus 1, or f of x is simply x minus 1. Okay, this was not asked by the question, but you can see it's actually quite easy to get once we have the line drawn. Okay, so there you go. Not a very long lesson. Hopefully you understand what I'm trying to show you here. Here are some questions that you can try. Let me know if you need help during the office hour, or just come see me for help. Okay, bye.